Hey guys, this is Mr. C, and in this video we're going to talk about residual plots. Residual plots. We're going to talk about these in the context of a real-world problem, and then we're going to talk about what is a residual plot and how you make them. And these are all EOC questions. First of all, here's our problem. It says Lionel made 4 different regression equations, A, B, C, and D, for 4 statistic studies. In order to determine if his independent variable and dependent variable for each study have a linear relationship, he creates a residual plot for each equation. Using the residual plots, determine which equation best identifies a linear relationship between the variables. Okay, so what you're looking for when you look at these is you're looking for the 2 variables, the plot, to have no correlation whatsoever. You want them to be almost random. Okay, so if you look at all 4 of these plots, and this is the way they do this, one way they do it. This one definitely has, it looks something like a parabola, right? This one definitely has a shape to it. This one is not going to be it. You don't want to have a shape to it. You want it to be random. That's not random. This one, B, is not random because even though it kind of spreads out as it goes, it spreads out in this funnel shape, which is what they call that. And so that right there kind of kills this one off. Neither of these, the variables, have a linear relationship. They have something else. If you look at choice C, this one, all the dots are scattered around randomly about the x-axis. This one has relatively no correlation. So right now, my answer of C is looking pretty good. Choice D, though, definitely has a line right here of dots. So D is not going to be it because, again, we're looking for something that does not have any relationship. Random, and there's a reason for that. So, but what do most students put down as their answer for this on the EOC? This one. And why do they? Because all throughout this problem right here, all they see is linear, right? And they've all heard about linear, and they know about linear, and so they go ahead and pick the one that looks like a line, and it's wrong. It has to be this one that's random. And again, there's a reason why they need to be random. So part B down here says, explain why the residual plot you chose above best identifies a linear relationship between the variables. And this is what we're going to write. Residual values are calculated as observed value. Now I'm going to write this in different color. Observed value minus predicted value. So why did I write that in a different color? Because that's the calculation to get the residual values. Observed value minus predicted value for a linear relationship. Most of the residual values should be close to 0. Should be close to 0 and should be randomly distributed about the x-axis. Okay, so if we look at that, we look at our 4 graphs and we say which one matches up with this explanation, that one because they're random. Not this one because it's linear, not that one because it's a funnel shape, not that one because it's quadratic. Even though these right here are the most common ones you see when it doesn't have a linear relationship. That's the one you want it to look like. All right, so now that we have that written down, now we can kind of take a look at what they actually have you guys do on the end of course test. And that's going to look something like this. Okay, so now it says, for a summer statistics project, Jace recorded the number of hours of sunlight each day at a particular section of the beach where he lives and the average number of people who visited the beach per day during those days. He recorded his data in the table below and then created a scatter plot and line of best fit. So you have a table of values, data. You have a scatter plot. You've got the line of best fit. Okay, so you got all this. Not that this right here really matters, because what they're going to have you do is plot the residuals down here. All right, so if you remember, for the residual plot, the residual values are the actual minus predicted. Okay, so I'm going to actually do this. I'm going to put residual equals actual minus predicted. All right, then to further help you out, the actual values come from the table or the plot, and the predicted ones come from the line of best fit. Okay, so how do we do that? Well, this is how we're gonna have to do it. So we have a line of best fit sitting here, and we have all these dots right here that are, some are on the line, some are not on the line. All right, so let's talk about 0. Okay, so 0, you have your line right there. Here's your line, and then you have the dot, the actual value, 1 unit below. So that's -1, that's 1 below. So for the residual plot, you're gonna plot that value as -1 because it's 1 unit below. At 1, it's right on the line, and so that has a total change of 0, like so. Okay? At 2, it's 1 above. So at 2, 1 above. At 3, it's 1 above. So now you're going to start to get the hang of this. At 4, it's 1 below. At 5, it's right on, so 0 change. 6 is 2 below, right there. 7 is right on. 8 is 1 above. 9 is 1 below. 10 is right on. And then that's all we can do. The rest of the residual plot can't be done. So let's take a look at our residual plot. Does this show a random type of a scattering? Definitely. I don't see any kind of behavior here. It just doesn't look like there's a pattern here. They're just kind of all over the place. And that's how it should look if the two things have a linear relationship. So we have talked this lesson about residual plots. You can come back and look at this video anytime you want. Remember to like my video, subscribe to my channel if you haven't already. That's a pretty quick lesson, and we'll see you guys later. Bye.